Chat session. This is a chat session for MGF 1107. The topics for tonight's chat session is on applications of linear equations, and relates to the textbook section (6.3). Strategy for solving word problems. Step 1. Read the problem carefully. Make sure you make notes of all the numbers that are mentioned in the problem. State the unknowns. Using a variable. If needed, write in terms of X other unknowns. Write an algebraic equation representing the problem. Show the work done to solve the equation. Write the answers or answers in a complete word sentence. And as always, check your work. These are good steps for solving any word problem. Now, there are many keywords and phrases that you can use in solving word problems. So we're going to take a look at some keywords and phrases right now. Okay, for instance, sum, we know means addition. So you could have sum of 5 and a number. And that would be written as 5 plus x, or some variable. We could say added to. That also means addition. But you reverse the order. So if you say 6 added to a number, this would be written as x plus 6. Even though the 6 was mentioned first, it gets written last. That's what I mean by reversing the order. Difference. That means subtraction. And you could say the difference of a number and 8. And that would be written as x minus 8. Difference, we don't reverse the order, but subtracted from, again, means subtraction, but you reverse the order. So this would be, if we have 8 subtracted from a number, that would be written as x minus 8, where even though the 8 was mentioned first, it gets written last. Times is another one. That means multiplication. No reverse order, though. Product means multiplication. Again, no reverse order. Quotient means division. And again, no reverse order. So these are some sample keywords and phrases. Now, when you are solving an equation, or solving a formula, means that you are isolating the variable on one side of the equation. Now, let's take a look at section 6.4. Chat session topic, linear inequalities in one variable. Textbook section 6.4. Now, let's take a look at some symbols. We talk about set, builder, notation. We talk about words, and we take a look at graph. Now, if we have the set of all x such that x is less than a, this means x is a real number less than a. Whereas in a graph, we put an a under there. And if we're talking about less than a, that means we're not including a, and we're talking about all numbers less than a. But if we talk about x such that, that vertical line means such that, less than or equal to a, x is a real number less than or equal to a. Then when we draw the number line, we have an equal sign. With the lesson or inequality symbol, but our closed-in circle now is shaded in. And we're still talking about less than a. And let's put the letter A under that shaded in circle. So that's less than or equal to a. Now we'll talk about what if we have x such that x is greater than a. So the x is a real number greater than a. And since it's greater than a, we'll have an open circle on a, and we'll shade to the right where the numbers are larger than a. Trace over the arrow to show it continues on infinitely. And let's put an A under our open circle. And the last one I'm going to show you is what if we have set of all x such that x is greater than or equal to a. So x is a real number greater than or equal to a. And since we have or equal to, we'll underline the greater than symbol. We'll have a shaded in circle. Again, we'll shade the number line to the right because we're talking about greater than a. And then let's mark the letter A under that shaded in circle. And these are samples of inequalities, what they mean, and how we would draw them on the graph. Now, a linear inequality can be written in one of the following forms. This is where we have a variable in the inequality. Ax plus b is less than 0, or ax plus b is less than or equal to 0. Ax plus b is greater than 0, or ax plus b is greater than or equal to 0. Now, I'm going to add in those equal to signs that I read. So that's less than or equal to, and this is greater than or equal to. These are called linear inequalities because they include the variable x, and the x is to the first power. Now, exceptions with inequalities. If you multiply or divide both sides of an inequality by a negative number, the direction of the inequality symbol must change. So, for example, if we had 7x, negative 7x is greater than 42. To get x by itself, we are going to divide both sides of the inequality by a negative 7. Well, since we're dividing both sides of the inequality by a negative 7, you'll notice that our greater than symbol became a less than symbol. So our final answer is x is less than negative 6 because the inequality symbol changed. Now, what if we start with x less than 5, and let's suppose that x was over the number negative 3. Well, to undo the dividing by negative 3, we're going to multiply both sides of the inequality by negative 3. And since we're going to multiply both sides of the inequality by a negative number, the direction of our inequality symbol must change. So our less than symbol became a greater than symbol. And remember, we started with a negative 3 in the denominator. Now, those negative 3's will cancel out, and we're left with x is greater than negative 15. But notice, each time our inequality symbol changed because we either divided both sides of the inequality by a negative number or we multiplied both sides of the inequality by a negative number. Now, let's take a look at solving a three-part inequality. Suppose you have negative 8 is less than 2x plus 10 is less than 16. To solve this three-part inequality, we want to first get the x term by itself. So what we're going to do is subtract 10 from all three parts of the inequality. Now we're going to simplify and we get negative 18 is less than 2x is less than 6. Now we want to get the x by itself, so we're going to divide all three parts of the inequality by 2. But if we had to divide by a negative 2, again, we would have had to change the direction of the inequality symbols, and it would have been all inequality symbols would have had to change, not just one, but both of them. This gives us negative 9 is less than x is less than 3. So x is some number between negative 9 and 3. Now, this concludes this chat session. Please let me know if I can help you in any way. I'll be glad to. You can call me, you can email me. I'll be glad to assist you. Thank you for watching this chat session.